let's get started. I'm so excited to have Tom doing a presentation. Like he said, he did some for us a while back, but then I was talking to him and some of the other people at Connexus, and they said that there's a bunch of new things they're doing to add to their system, and they are they're a different co-op in the sense that they have decided to add more renewables and more storage and everything. So I think it's a great story for all of us to hear and what's going on new. Uh, our speaker is Tom. I never can pronounce it, Tom. It's Guttormson. Anyway,
Guttormson. Guttormson. Put the emphasis on the second syllable with some Norwegian twang, and then you got it.
all right. Well, anyway, I'm glad you said that. We'll move on. He's a principal technology engineer for Connexus and part of the power supply team. And he's got, I believe, a really exciting presentation for us. So, Tom, go ahead, take it from here.
All right. All right. Thank you very much. Well, this will be fun. This will be fun. So, as you mentioned, we did present part of this a number of years ago on our first battery storage project, and I do have a little bit of material on that. So what I wanted to do here is go over Connexus Energy's portfolio of renewables and then do a kind of a quick look ahead at what we see coming down the road, excuse me, for additional renewables and some of the other load control programs that we're embarking on. And hopefully that will paint a little bit of a picture as to where we are and our intent of why we're doing this and where we're going. So bear with me here as I do the screen share again. I'm going to go and click on this one, do a share. I'm going to drag and drop this thing in here, make it big. Do this share here, change the display settings so that you can see the whole PowerPoint presentation without the notes, because I'm not using the notes anyway. So does that look good?
Looks good.
Okay. Okay, so little bit about Connexus Energy. We are the largest co-op in Minnesota. I think we're the 14th in the nation, something like that, in terms of our number of customers. So we just crossed about 150,000 members across 8 counties. Our summertime load can go anywhere from 500 up to about 550 megawatts on a good hot day. About 220 employees, and we cover about 1,000 square miles of the area, including the north suburbs of Minneapolis-St. Paul, and then to the north and to the northwest up to St. Cloud, 9,500 miles of distribution plant. And right now, for renewable sites and storage sites, this is what the system looks like in terms of what we have where and of what kind. So the ones that are just totally green are grid, and this is all grid scale, are grid scale solar only. There's a 3 megawatt plant by Princeton, a 7.2 megawatt plant up by St. Francis. And here at our headquarters, we have a community solar system. It's not real big, it's just under 200 kilowatts, so a smaller system. And then we have our Ramsey storage and solar. That's solar and storage that are combined together. That is 3.4 megawatts of solar, a 6 megawatt 2-hour battery. And then up at Athens, that's actually 2 different systems on one site, total of 6.6 megawatts of solar. That is 9 megawatts of storage, 2-hour battery. And then just recently, we put a 2.5 megawatt battery system interconnected with a substation. And I'll talk about that a little bit today because that's new. So that is what our corporate portfolio of grid connected solar and battery storage is as of today. So the first one we did was this community solar located on our campus here in Ramsey. This started out as a 225 kilowatt system, was first put in service in 2014. About 10 years into service, the inverter failed, So we had to get rid of the central inverter and put in some string inverters. And with some of the degradation of the panels over time, that type of thing, it's about 180 kilowatts right now, but it's still in service. So this is community solar, where we allowed members to buy a solar panel or enough solar from here to supply their house, but not being located on their own property. It's here on our property here. So that was a way to have net metering solar with their members without them having to mess with the infrastructure right here on campus. So that, as I mentioned, has been in service since 2014. Kind of a nice aerial shot right there. Somebody was pretty good with the drone.
Yeah.
Then, starting in planning in about 2016, we wanted to look at energy storage coupled with solar. And the primary business case for this was really demand response. So we purchase our energy, over time, and then monthly we would get a demand charge that would be equal to so many dollars per kilowatt that we would pay out for a demand charge based upon whatever the hourly peak is of that month. And that, of course, those charges were a little spendy. So we thought, is there a way we can put solar out there, get a reasonable price on the solar, have that online all the time, and then charge the batteries up and dispatch them over the monthly peak to try to reduce our demand charge? It's basically shifting energy. And so the way this works is we put in the solar system, and this is the solar systems I just mentioned, one at Ramsey and one up in Athens Township. Put in the solar systems, tied them to the grid. We established a power purchase agreement with the solar developer. So we don't own the panels. We hired a developer to purchase, engineer, and install, and then we purchase all the energy via a power purchase agreement. Then we put the storage facilities in. And the administrative rules were, if we were to use the storage for demand response, in other words, charge the batteries and discharge them at the time of peak to reduce the power consumption coming from our substation meters, our wholesale supplier, all that energy would have to be charged into the battery from the solar system. So we devised a way to do that and make it legal and everything, so that met everybody's administrative requirements. And that's what the batteries are for. So basically it's shifting. The batteries are not a generator, they're a garage. And we're purchasing the electrons from the solar system, storing them in the garage, and then taking them out when we need them in order to reduce the demand on the system at system peak. So we did that through 2022. In 2023, we changed our relationship with our power supplier, Great River Energy, so we're no longer a member. We're more of an independent utility, still buying the bulk of our power from Great River Energy, but now we're also purchasing power out on the market. And so we're not subject to the rate structure of reducing demand charges monthly anymore. So what we did recently here, starting in 2023, is we registered all the batteries with MISO as load modifying resources. So in this situation here, where MISO gets into a situation where they have a capacity or a generation emergency, because over the MISO footprint and us being in the northern part of MISO, they can actually tell us to dispatch the batteries for MISO purposes. So we get a monthly credit for having those batteries available for that service to MISO, and they can call on them as they need for their purposes. And since we've been doing this, we've had a couple instances where we came close to needing to deploy them. We had them all charged up and ready to go, ended up not needing to pull the trigger, but still a very valuable asset for that. So that's how those are currently used. So here's just a couple of top plans of this. This is our Ramsey site. This is about 17 acres. Whoops, I got that.
Yeah,
I got the wrong title in here. That's a
there you
Ramsey
go.
site, but it's 3.4 megawatts of solar and 6 megawatts of storage. Sorry about that. I'll have to get that fixed. And here's the Athens site. So this one is 6.6 megawatts of solar and 9 megawatts of storage. It's actually two systems, about 2/3 and 1/3 size. The 2/3 larger size goes to the north, and the smaller one goes to the south. So two systems, but one site. So there's some details here if anybody's interested in looking at how many batteries are in each of the containers. Each of those containers is 1 megawatt in capacity, 2-hour battery, so 2 megawatt hours. And for example, the Ramsey site has 6 containers, so that makes it a 6 megawatt 2-hour battery. Lithium iron phosphate is the chemistry, and that is a good chemistry for this type of application, and it's not real volatile to explode or something like that either. Pretty stable. Here's a quick picture of one of the cabinets with the doors open up. You can see the battery racks there. There's an inverter up there and all the different batteries that are all wired together into that inverter. I think there's 9 inverters in each one of those containers, if I remember right. And then for the solar, we use string inverters, not one great big large inverter here, or uh, or the larger ones. If one fails, and of course you have more of the site out. This particular site, Ramsey, has 27 string inverters. They've been very reliable. We did have one of them fail once, and it just takes out a very, very small part of the system, and everything else keeps operating. So, string inverter for a large system like this is a good way to go. This is a one-line diagram showing ownership. As I mentioned before, with the solar, we hired a developer to provide and own the solar, and we purchased the power through the power purchase agreement. Well, same thing with the storage. We don't own them. We contracted, in this case, with Nextera Energy, part of Florida Power Light, and they engineered and own, installed, and managed the batteries, and then we have the control system to charge them and discharge them at will. So all the red facilities here are owned by Nextera. All the green facilities are owned by Engie, and all the black is the Connexus Energy owned interconnection equipment, which is a master meter on the site, a main breaker, and then the disconnect switch that goes out to the distribution grid. All these systems are connected into the live distribution system. None of them are home runs back to the substation. So we had to make sure we did our system studies carefully and had voltage control, all that type of thing, to be able to tie that into the distribution grid. And since we put this in, it's just worked very, very well. One of the things we had to do also, the storage people, Nextera, wanted to get that tax credit that was available to them. And the trick there was all the electrons coming from solar, none of the electrons can go through utility-owned equipment. In other words, can't go through the grid. It's got to go from solar into storage. So the ownership is set up here so that the batteries will charge at the same rate as what solar production is, and the electrons all go then from solar to storage and not through the utility grid, and that met some of the legal requirements for the 30% tax credit. It's a fun little thing that we did there. Here's a couple of construction pictures. This is the Athens site. You can see the solar field out there, and the massive foundations for the batteries. They are really huge. Those things are heavy. And here's all the inverters and the interconnection, utility-owned interconnection stuff out to the right. And the solar developer and the battery developer all own the transformers. Interestingly enough, the secondary side of the transformers, or I should say not, well, yeah, the low voltage side of this transformers is 600 volts AC. That's not anything that we have in our standard fleet. So the solar and the battery owners own all the transformers and installed those. Another shot of the Athens site with the battery containers all installed and soon ready to go. This is a quick shot of what this looks like. This is a trace from our SCADA system, and you can see here that the purple line here is the solar production through a day, very sunny day, a little bit of clouds right there, but perfectly sunny day. The orange line is the irradiance of the sunlight on the solar to develop the solar production. The blue line here is the battery. So right here, you can see in the beginning of the day, we're going to dispatch these batteries over peak in the evening. So we're charging up the batteries, and then when they get fully charged, then they just sit there at rest. And then we schedule them to discharge. At this time, it was starting at 5 o'clock and going to 7 p.m. So you can see now they're discharging all the way up to full throttle output for 2 hours, and then it backs down to the state of rest. The green line here is the net power flow in and out of the site. So that is a day that we charged them up during the day and dispatched them in the evening. And then the next morning, charge them back up to resting state of charge, which is about 50% for these batteries. And then they just sit there at rest until the next time we discharge them. So just a little snippet of what it looks like on the grid with the power flow.
Mhm.
Well, that's what I have on. Again, we went over this a few years ago on the solar plus storage sites. So would there be any questions or comments
Tom,
on this part? Yeah.
Tom, I want people to understand one thing that you said that I think I understand. When you talked about your main facility at the headquarters, you
Mm-hmm.
said that the customers could buy some solar there. And
Yes,
so it's a community solar garden. To the
that's
best
correct.
of my knowledge, you guys are the only co-op in the state that's doing that. Is that right? Because I know Dakota
Mm.
Electric has solar, but I mean, it feeds into their system, but nobody can buy it. And well, there might be another co-op west of town, but you're one of the few that did that, right? Or no?
I thought there was others that have done this, but to be honest with you, I'm not 100% sure, and I cannot name who that might be. I thought there was some other ones that set up maybe smaller systems, not quite as large as this one is. I could be wrong on that.
Okay, I could be too. So the only other question I wanted to ask you, when you're talking batteries and all that, have you guys done any investigation of the iron air batteries?
No, we have not. I have looked at that at trade shows and done some reading up on them. Looks very intriguing, non-volatile certainly,
Yep.
but yeah, we've not looked out on trying anything there. So when we went out for request for proposal on this, we figured that lithium ion would be probably the chemistry of the day that would be used. And there was some looking at cobalt. The cobalt was in short supply at the time, so we ended up with the lithium iron oxide, which has been a pretty popular, as I mentioned, chemistry. But we can open that up for whatever chemistry the battery supplier or developer would like to put forth. The
Mhm.
challenges here is this particular project is we didn't treat this as a research project, didn't even treat it as a pilot project. This was a um, cost savings project. And oh, by the way, let's not break the grid while we're doing this. We made sure to do our studies that the grid was going to accept this okay. So we didn't do this because the grid needed it. We're trying to do this to save money and operate more efficiently. So with that, of course, that then lends itself to getting the most economical bid you can for the product that's going to do the job.
Right. And uh, can you just quickly explain MISO to people that maybe don't know what that is?
Sure. MISO is a regional grid operator, Midwest Independent. Oh boy, I can't even remember what all the terminology is, and I should know that. But MISO is the organization that monitors and manages the bulk power flow across the whole Midwest part of the country, and it goes all the way from Minnesota all the way down to Louisiana. There's a north, a central, and a southern part of MISO. So what they do is also help to manage the different transactions in the load flow between generators and across transmission lines, managing to make sure that the power can get to the load and all those types of things across the whole Midwest. So there's different power operators like that across the country, and MISO is the one that we are in.
Yeah. Okay. Thank you.
Yep, regional operator. That's what it is.
Yeah.
Okay. Other questions on this so far? Anything? Okay, I can't see hands, so you guys will have to.
Yeah. Raise your
Uh,
hand if you have a question. We'll call on you.
yep, yep.
All
Okay,
right.
so
Let's
go
move
on.
on.
Go on to the next section here. So a next battery storage project we thought we want to continue with some type of a storage plan and other projects that are valuable to continue to get the experience and see if there's other opportunities to do cost savings. So
John,
we
we do
thought,
have a
what?
question right now. Sorry if we
Okay, yep,
could
yep.
go back. John, if you want to unmute and you could ask a question.
Yeah, John Crampton, go ahead and unmute.
Okay, can you hear me?
Yes, sir.
Yes.
Okay, how much of Connexus power comes from renewables and battery?
Oh boy, I'm going to have to sit here and do the calculation off the top of my head. We have right now 20 megawatts worth of solar out there, and if our peak is 520 megawatts, then that would be 20, enter 520, divide, about 8%. Is that right? Did I do that right?
Mm-hmm. I don't know.
Yeah, that sounds about right. Yeah.
I can't mess with my
And what
calculator.
does LMR stand for? Load modification something response?
Load modifying resource.
Okay.
Resource.
And so basically what that is we have resources. There's the term DER, distributed energy resource, that can be solar, it can be a battery, it can be diesel fired generators, can be gas fired turbines, or some form of energy supply on the grid somewhere that is not normally run as part of base load, probably because of cost or limitations on production, such as a battery, but we can deploy them if needed during peak times that will shave or actually shave the demand off the other generators, off of the baseload generators that are on the grid. And so it's just a way to reduce generation and reduce some of the transmission flow when there might be some constraints or some heavy loading on the system, to try and relieve some of that loading and help the system stay stable. So that's a load modifying resource.
Tom, just to follow up on John's question, as far as co-ops across the country, are you guys about normal for the amount of renewables, or do some have a lot more?
Oh, that's a good
Or do you
question.
know?
Uh, Off the top of my head, I don't know what I really don't know. We're probably a little farther along than storage than most co-ops are. There are other
Yeah.
co-ops that have batteries out there. There's probably quite a few co-ops in the southern part of the country that have a lot of solar. There's not a lot up here. We probably have more solar than most of the co-ops do in the northern part of the country. But in terms of what that looks like, what our portfolio looks like compared to other co-ops across the country, off the top of my head, I'm really not sure.
Okay. Okay.
Good question. Any others?
All right. Let's proceed.
Okay. Next battery project here. So what we're trying to do is, again, looking at economic things to help us be more efficient with our grid operations. We've done case studies with our members, and they want basically three things. Number one, good prices. So keep the rates down. Number two, reliability. Don't break the grid. Number three, be as easy to do business with as possible, make it convenient. In doing all that, our members certainly will support us being green and working with renewables. However, in so doing, see points number 1 and 2. Don't raise the prices up just to be green, and don't break the grid or hurt your reliability in the process of doing so. So when we're looking at doing these solar projects or storage projects, they need to meet that criteria. They need to help us either maintain or reduce our prices to our members, and either, don't put additional risk on the grid, or if possible, make it more reliable and stable. So those are a couple of key criteria. So what we did, looking for a substation project, we thought, is there a substation out there somewhere that has enough load on it that we might have to rebuild that substation, but it's not so bad that it really needs a huge major project to rebuild it that costs lots of money and gives us more capacity than is really needed. And also, if we have substations around the edge of our service territory, if one goes out, then it's a little bit challenging to try to serve that load from an alternate source. And we have a substation called Vadnais Heights Substation that's down in the city of Vadnais Heights that's just like that. That little part of our territory is almost like a little island by itself, connected to the rest of our territory by a fairly narrow corridor. And so we have a substation there that has 2 transformers. If that whole substation goes out or the transmission fails, we have to backfeed it from an alternative source that's up this narrow corridor here. And that's really challenging to do, especially when the weather's really hot, it's nip and tuck. And if one of these transformer fails, we have to pick up the load from the other. Again, there's parts of the year where it's very difficult to do that. And we don't want to be in a situation where if we have an outage or something like that, we cannot turn the lights back on. That's not acceptable. In this particular place, the load around here, that the area around here is fairly well developed, so there's not a lot of growth, but the native growth is enough such that under those backfeed scenarios, these transformers could be overloaded and we need to do a substation project. But doing a substation project here to upgrade it in order to meet that deficit would be a major project, and it would just be an overkill of capacity. And we thought that would be a good opportunity to put in a battery with the substation and have that battery charged and ready to go during those peak times, so it could serve as a supplement of energy to feed the grid if we have one of those backfeed outage scenarios, but it's not such an overkill. So that is what we looked at doing. And this substation really fit that criteria. So we did some study on that, and we thought, let's go out for bid and see what it costs to do this and see if this is a cost-effective solution. So it's a low growth area, edge of the territory, long-term needs, probably not a lot of growth, and this seemed like a good right-size solution. So then we thought also, do we want to do this again where we put together an energy storage agreement, which is where the developer owns the battery and manages it and we dispatch it, but it's not really ours. We have a rental agreement. Or do we want to try owning this and get some experience in the ownership of this type of facility? So we went out for bid and went out to a number of different battery developers and set up our RFP so it could be either ownership or energy storage agreement, either one of those. We asked for both. And we set this up as a 2 megawatt, 4-hour battery, and we set it up for a 20-year lifespan. And that was what we thought we could defer a legacy substation rebuild with that size of a battery. So some of the bids came in energy storage only, some of them came in ownership only. So we looked at all of them and thought, let's pick the best cost solution. And we ended up back again with NextEra Energy with an energy storage agreement. So again, NextEra Energy owns the battery facility, connecting it to our existing substation, and they maintain it and we dispatch it. Then we went with a little bigger system, 2.5 megawatts, to help it be more cost effective for them. If we went to a little bit bigger size, they were able to use a lot of the standardized equipment and material that they typically do for other installations, and it just ends up being that size. We allowed them to go a little bit bigger size. So that's what we ended up doing. We started the concept of this project back in just talking about it in 2021. We started doing actual system planning in 2022. So we went through the whole process of the RFP process, design selection, signing all the agreements, getting all of our permits, working with the city to make sure they were okay with it, conditional use plan and all that type of thing. And then went in and did all the engineering and construction and testing it. And by the time we got through everything, we placed it in service on May 28th of this last year, 2025. So it's not been in service a whole year yet. And that was from concept to putting it in service was a 4-year time frame. So that's been in service since then, and it's been working very, very well. This is a one-line diagram of this. So we have the substation transformer, and we had one feeder bay in that substation that was not used. So we dedicated that feeder bay to interconnecting with the battery system. No solar here, just the battery. So we go through there, through the substation, and Connexus installed all the substation gear. And then we have a master AC disconnect switch that separates Connexus-owned substation from the NextEra-owned battery facility. There's a big step-up transformer. And to start off with, there are 3 different battery containers and space to put a 4th in, such that over time, if the batteries degrade and we have to maintain the contract level of capacity, at some point in time after a few years, they'll put in a 4th container as an augmentation. So that's what that looks like. It's all charged from the grid, discharged back into the grid. So we charge it up during times that we're not at peak and have it all charged and ready to go on those heavy load days through the peak. This is a plot plan of this. So Connexus Energy owns all the existing land where the substation is, and we own the substation that is bordered by this fence line right here. So what we did is there's enough space on the back of the property to physically carve out some land. Had to cut some dirt out of there and put a retaining wall in that was sufficient enough to put the 3 battery units, the transformer and inverter, and all some ancillary equipment, the disconnect switch, and room for a 4th battery, all in that area in the back. Can't see it from the road very well. It's nestled back there, yet it fits really well. It was a bit of a tight fit, I should say. The end product was it fit pretty well. A little bit of challenge in coming up with the design to get there, but we made it. So that's what the top plan of this looks like. We've never done this before. NextEra had never worked in building a battery unit like this close to a substation, actually with an adjoining fence. So this was a net new for both of us, and we had to work very closely together, some good teamwork there to pull this off and make it work. So this is a little profile of what this looks like. So this bottom line, this blue line, is energy flow to the battery. So when it's up like this, we're charging the battery, and the battery is at rest, and then we discharge the battery, and then the battery is at rest again here. The red line is the substation transformer load that the battery is connected to. So right here in the middle, where you can see the yellow line, that's the other substation transformer, and the red one is the one it's connected to, you can see that's where the peak load is. So what we're trying to do is when the sum of those 2 transformers equal a value that's equal to or higher than what the rating of 1 transformer is, we want to have that battery charged up and ready to go in case we need that capacity. And the theory there is if we lost one of these transformers and the other one had to pick it up, we don't want to have to overload that transformer. And so that's what the battery would be there for, is to supplement that power need. So here you can see earlier part of the day, we're charging the battery up. So here's the energy in the battery. We charged it up. It's all full, ready to go. Okay, we didn't have an outage that peak, didn't need it. Discharge it back to a resting state of charge and drop it back down. Next day is another potential peak day, so we go through this again. And we can do this on an ongoing basis for much of the year. We contracted this battery to be able to have 150 of these cycles per year. NextEra has also told us if we have a number of consecutive days, 3, 4, 5 days in a row where we have this condition, we don't have to discharge it and charge it, discharge it, charge it. We can just charge it and leave it charged up if we need to. And then that would count, each day it's fully charged would probably count as a cycle. So we can do that as well. But this is what we've been doing. And it's been working pretty well for us. Now the loads are down in the springtime. March, April, May, and towards the end of May, we start seeing our peak loads creep up again with the warmer weather. Then we'll go back into cycling this again like this. So that's the use case for that. So what that did is that helped to avoid an expensive substation upgrade and keep the existing transformers there without having to do a major upgrade, and just planted these batteries in the backyard of that substation, if you will. So those batteries there, when they're fully charged up, have enough energy to feed about 1,000 homes during peak load. That was a cost-effective solution. Doing that to meet the capacity need was less cost than rebuilding the substation. We would have had to replace both of those transformers to achieve the same thing that what we're able to do with the one battery. And we learned a lot through that, so hopefully we're chalking up some more experience for the next project. Some challenges was, as I mentioned, the design layout for that was, we made it work. It was a little tight to do it on that land. NextEra worked with us very carefully and did things differently than they would have done with the space we had, but all worked out really well. There were some supply chain issues with this. NextEra was very challenged in getting some of their supply chain, and that ended up causing a schedule delay. That put some risk on us with some of the loading out there, but at the end of the day, it all worked out very well. So that was great. So here's some pictures. This is a site preparation. This is the area to the west of the substation existing fence where we had to carve some land out and flatten it out in order to make room for what we call the best yard. And there we're putting in foundations for the battery containers. They used round cylindrical foundations instead of rectangular ones. I'm not sure I ever learned why, but they worked out really well. Then on the south side of the substation, we had to build a little bit of an access road. This is all still within our territory, but we built this in order to be able to transport in or drive in a crane and set up a crane and then back a lowboy in with the battery containers and pick them up and swing them around and set them down on the foundations when we built that. So city let us build a little additional approach into the substation yard in order to accommodate that.
Tom, any idea what those containers weigh?
About 80,000 pounds a piece.
Okay.
They're big and they're heavy.
Wow.
So this was 120 ton crane, or no, what was the size of that crane? It was a big heavy duty crane. The crane operator drove that thing along the south side of that substation and managed to plant that thing in the backyard. He was very, very good at positioning that in order so that the flatbed could back in with the battery container on the south side of the substation. The crane would pick it up and then they'd swing it around very carefully and set it down on the north side of the crane.
Wow.
So here's a picture of them offloading off the flatbed and then swinging it around to set down on those foundations. I was out there watching that. That crane operator was really good. It was incredible to watch. So here we're setting the containers down. This is to the north. This is the north looking to the south where the crane is. You can see him coming over with this container and just about ready to set that down. And here he's got two containers down. And there's a picture of the finished site.
Wow.
So this is the westerly side of the battery yard. Here's the westerly side of the existing substation yard. And you can see that's all contained. Here's BESS 1 and 2. There's BESS 3 over there. Room for a fourth one right down there. And in the middle is a container for the step-up transformer and all the inverters. And then on the south side, way over here, you can't see it, but there's a station auxiliary power transformer for all the station aux load and SCADA communications cabinet and all that type of thing. So that's the finished site.
Tom, just in a ballpark, did you say 50%, 30%? Do you know?
Oh, I got to do the math in my head. Probably 30, 20
Okay.
to 30.
Okay.
It was a savings. The interesting thing was if you took the cost of the capacity that would have been added by putting in new transformers, the dollar per kilowatt of capacity would have been less for the substation rebuild. But that was building capacity that was a gross overkill and capacity we'd likely never use.
Yeah.
So here, this is a just right size system. It got us the capacity we need to defer that transformer upgrade for either many years or maybe even indefinitely. We don't know. We'll see how that goes. And at a higher dollar per kilowatt of capacity cost, but looking at solving the engineering problem was a cheaper price. So that worked out really well. We spent a lot of time on that business plan. Good question. Other questions on that so far? How are we doing on time here? Okay.
We got about 15 left.
Okay. So some lessons learned here. Batteries are still in development. There was quite a bit of design change between these batteries here that we deployed in 2025 versus the ones that we did 7 years ago. And so supply chain is still a challenge. A lot of the lithium is still coming from overseas. And something like this, especially we dellied up the responsibilities here where Connexus did all the ground preparation and the permit acquisition, and Nextera did the rest of the design. I think I would more have the battery supplier do all of that, so it's more of a turnkey. There was some confusion and questions going along. Wait a minute, who's doing what part here? That was a lesson learned. Good lesson learned.
James has a question.
Yep.
Go ahead, James. Unmute yourself. I don't know.
Go I got it. No, I got it, Doug. Sorry, I'm working on my phone. The screen options are hidden for a little bit. Sorry.
Okay.
I was just wondering I know the lithium ion batteries are very sensitive to cold temperatures, or actually can't be charged when it's below like minus 14. So has the heating options between like this battery container and the other one changed much? And how much of a burden is that, whatever, I assume you're using electricity to keep those containers at a temperature where the batteries can charge and discharge?
That's a really great question.
Yeah.
So both of the battery sites, the containers are all fully enclosed, insulated, and have HVA systems in there with controls to maintain the batteries within a specified temperature range. And I can't quote what that range is off the top of my head, but it's kind of interesting. And then we have Station-Knox power that feeds those. So the big HVAC in all those containers, and there's a Station-Knox power system that feeds those and maintains the environment. And I'll tell you, in the summertime, when we run those batteries, so there's a lot of power running and it's hot outside, the HV systems are really pulling a lot of Station-Knox power. I've noted that. But it's worked pretty well. And actually, to this time, we've never had an issue with hot or cold in battery performance. The HVA systems have, or the environmental controls have worked suitably enough to keep the batteries in good operating condition.
Yeah, great. Peter, you got a question?
Kind of two questions, basically about the various precious metals needed for the. Am I good? You hear me?
Yeah,
okay?
you're good.
Yep,
yeah,
yep.
You're good.
Precious metals, where are they available from? Are some of them from northern Minnesota, the areas in question, like near the boundary waters, or other countries? Second question.
Boy, yeah. Okay.
My second question, I'll go ahead and answer that one.
Well, I would actually have to go to the supplier of the batteries themselves. On the first one, the supplier was Lishan, and they are a Chinese company. And so the batteries themselves, including the design and the manufacturing and everything, all came from China. So they're shipped over from China and assembled here in the containers by Nextera. So the lithium is largely supplied from China. The iron part, that I don't know if that was sourced locally or also sourced overseas, but those batteries were built overseas, so that's where they came from. The new ones, I don't know how those are sourced. That's a good question. I'll have to go look that up.
Okay, fair enough. I'm wondering also, second question, data centers going up everywhere. What effect and how is power provided? Can renewable energy provide that power?
Boy, that's a real challenge because the data centers can really suck up a lot of power, and that you're not going to get that through the distribution system. That's going to come off the transmission grid, and that has really been putting some additional burden on transmission grid where there are large data centers. So I think that's going to depend on where those things can be put. Of course, you need other things along with that. You need water supply and some other transportation services and that type of thing around where the data center is going to go. So I think there's still some open question on how that's going to be. Are some of them going to actually build some of their own power grids or power stations to self-support? And if so, will that be a lot of solar plus storage in order to meet that needs with a utility backup? That's a concept. I've not studied that a whole lot at this point in time, so not sure how that's going to go. Today, that's putting some load on the transmission system. Moving ahead, I'm wondering if there's some way for some of those power needs to be done independently with some renewables. That's a great question. If we could go back to that in about 8 years, you let me know what you find out.
I think it's a question we'll have for future Thursday nights.
The data center going in at Rosemont, I've driven by it a number of times, and holy mackerel, the electrical equipment that's in that area to feed that thing is amazing.
Yeah. Those things take a lot of power.
Yeah.
It's amazing. Yep. Good question.
Yeah, real good. Pete, you got a question?
Yeah, I got a comment. Lithium iron phosphate batteries are typically used upwards of 60 degrees Celsius, so I'm a little surprised that any cooling is needed on these battery housings at all in the summer, unless you really are pushing them that hard. Otherwise, I would think ventilation would be sufficient because, of course, we don't see temperatures above 40 C in Minnesota. The other thing is, for the other Peter, the lithium iron phosphate battery doesn't have strategic metals in it. It's a pretty simple chemistry with made of commonly available materials.
Got it.
Okay, good. I appreciate that. Thank you.
Yeah.
Also, thank you.
All right, we better keep going so we can get her done.
Yeah, okay. Just a couple things where we're going. Oh, boy. So what are we doing in the future? Of course, there's the mandates with renewables. And here's how we're looking at managing this. Our strategy to meet renewables is, yes, we're still going to try to develop some local solar. We're going out on the market to buy solar and wind. There's some consideration of buying nuclear. There's some consideration of buying or even partnering with some local hydro, small size. But we'll look at whatever portfolio we can and have it in some type of a diversified manner just to try to optimize as best we can both economics, again, back to that, and to keep our own grid reliable. So that does include building local solar. We have another 10 megawatts of solar sites that we're currently working on right now, just starting construction on one. We're still doing the engineering on a couple of others, so we'll continue to do that. So we do have a portfolio of more solar localized and more storage in our long range plan as well. So two things we're doing is we're still doing load management. So some of that was legacy, but we're using new technology to do that. So we have load management to cycle or shut off irrigation load on our system during peak. We still do an air conditioning program. I've got some other stuff on that in a little bit if we have time. But basically a Wi-Fi thermostat program where we can control through the Wi-Fi system a member's thermostat and pre-cool a house a little bit during a control time, raise the temperature up 4 degrees, and then when control period is done, bring it back to where it was. And the air conditioner doesn't run. It shuts off during that control period unless the house gets too warm above that 4 degrees, and then it'll start running again. That's been a really successful program. And then we do have more program with electric vehicles too. And I've got slides on that. If we don't get to that, you can go look at them after this is saved. So long term, we put together a resource plan, and that's looking at the whole portfolio of solar and storage in our own territory, plus what we'd have to buy on the market to meet our whole energy needs program and stay within everything being supplied by renewable energies. So that's in the plan, and hopefully we'll be able to do that and maintain it over time. So that's kind of a look ahead. More solar and more storage to come. We will not be building any wind in our territory, but we are buying wind on the market. So that's just a quick snippet look ahead. Okay. Any questions on that?
What do you see as the most feasible? It sounds like solar is definitely in the future.
Yeah, it is. Of course, the challenge with that is it takes up real estate.
Yep.
It is stable. It doesn't take much maintenance. It just works, except when it's covered with snow. But yeah, there'll be more solar. It's just a matter. The challenge there is still some supply chain, because a lot of our solar panels are still coming from overseas. So we'd like to see a lot more local development and manufacturing of solar, so it's more locally available rather than going overseas. And then it's the permitting challenge, finding the land, and then having some happy neighbors next to the solar sites.
That was the other question I wanted to ask you. Have you guys looked at doing anything with Helene? It's now building their solar panels up in Rogers, Minnesota.
With who is that again? Sorry.
Have you looked at the company called Helene? They're in Mountain Iron, Minnesota, and
Okay.
Rogers, and they are made in Minnesota, so to speak.
Yeah.
And they are American made now.
Yep.
You know,
Yeah, we've not gone out and looked at them specifically. We're still going out to the solar developer and
okay.
having them do the supply chain.
Yeah.
So that's something maybe I could ask our developer. I haven't asked. I don't know if they've gone to look at them for sourcing the panels or not. Good question.
Yeah, it'd be nice to have local made.
Absolutely.
Kim, you have a question?
Hey, how are you doing? Thanks for your presentation, Tom. I just wanted to ask you a couple of questions. One, what's been happening in regards to data centers in your area, and are there plans to work with batteries and renewables as a way to solve, providing that energy need there?
Sure. We have had some developers ask and look at a couple of different sites as possibilities within our service territory. The challenge is, again, on the sizing. How do you plan for what can they start off with as a smaller system and then build into it over time? Because the challenge is with the amount of power it takes to do that, that's nothing we can provide through the distribution system. That's got to come from transmission and other generation around the area. And so they need to go and work with the transmission companies to see what is there available for transmission and generation capacity in the area. And if upgrades are needed in order to provide as much power as what needs to go through the transmission system, then they need to get in the queue with transmission upgrades with MISO and transmission owners. And the challenge is, we'd like to build that data center like now, and it just takes a while to go through all the process that's needed to get the capacity on the grid through the transmission system. That's where there's a challenge.
Mm-hmm.
So we've had people approach us, but there's nothing that we as Connexus Energy can really do other than, gee, we'll help you work with the transmission company to or send them to the transmission company here's who you go talk to. And for any local power needs, we could certainly do what we can there. But for the big bulk stuff, that's got to come from transmission.
Mm-hmm. And I'm also just curious, do you have any wind in your portfolio at all? Is that something that you bring in, or how does that play into your renewable energy mix?
Yeah, we do. We would not likely be building any wind plants within our service territory. There's just not a good spot out here where there's enough open area to do that. But we do have wind in our long-term resource plan for purchasing. So where there's wind generators available, there's some capacity and some energy available that we can purchase, then we would certainly do that. Yep.
Some of that wind generation, does that come from GRE?
They don't own wind generation, I don't think, but they also go out in the market and purchase.
Yeah.
Yep.
Okay. Kim, did you have anything else?
No, I'm good. Thanks.
Okay.
I was just gonna. Oh, go ahead.
Go ahead, Tom. I'm sorry.
I know we're short on time here already. Wow, the time goes fast. I hope
when you're having fun.
I didn't want to get into too much detail. I was just going to give you a high level here, but boy, ask an engineer a question and that gets a little dangerous.
Yeah.
So we're also doing some things with electric vehicles. And so we've got a program here for pricing for electrical vehicles, and we want to promote this. We want to promote electric vehicles for, like everyone else, for saving on the carbon footprint, and how can we help our members afford get the best pricing they can for the electrical vehicles so they're as affordable as we can, and at the same time do it in such a way that it's not putting a strain on the grid during peak time. So we've got some different rates available that I'll go through here in just a moment, but you can see on the slide here.
I love that slide. I love that picture.
Isn't that cool? Got unleaded gas here, and we got so many cents per kilowatt hour. So the concept we'd like to help promote is, rather than a gas station, can we have a fueling station? Now, of course, the question is, what is this going to look like if a lot of people get electric vehicles and you got a whole row of charging stations at the fuel center, and you can't fill up on electricity as fast as you can fill up with gas? Don't know what that's going to look like yet, but you got to take some steps to get there, right? So this is a concept. So in our territory, we have a process that was actually developed by one of our own in-house data scientists here on where to track where the electric vehicles are. And so this is what we thought we saw, and then to get them on our programs, on our pricing programs, where we can get them a good rate. So this is what it looked like in 2018. Here's what it looked like in 2021. Here's what it looks like in 2025. So we're seeing an increase in electric vehicles out there, and we're going and marketing to those owners to see if we can get them on one of our good programs. So we have a time of use rate, and that incents you to charge off a peak, in the middle of the night or something like that. And we've also developed a program where, rather than doing it 7 cents a kilowatt hour and, okay, how many kilowatt hours did I use? So what's my bill going to be? We can charge a flat rate of so many dollars per month, up to 600 kilowatt hours of charging for that month. Or if you charge more, we'll give you 1,200 kilowatt hours a month for $50. So that's a little bit less cost per unit. And then the member or the owner knows what he's going to pay per month without having to wonder if he varies his charging, what it's going to be. So some different things with that we're trying to do. We have to kind of watch how much the charging is here too, and what times of day, because if you get too many people charging during over the peak time of the day, then we're going to have a strain on the distribution system. So that's one thing we want to incent the off-peak charging to try to help save on the grid. So those are some things we're doing. We also work with a developer to put charging stations in all the homes that are going into a particular development. So we did that with one particular developer over 3 different subdivisions, and offered some pricing incentives and that type of thing for people to get in and bring their electric vehicles in there. We're hoping to do that some more moving forward with some other developers. So we'll see how that goes. So that's just a couple different ways we're trying to help promote the use of electric vehicles. Skip over that one there. This is kind of interesting. This shows a 24-hour time period of the electric power usage of an electric vehicle user. And here he comes home and uses his vehicle during the day, plugs it in, and this is 6 o'clock p.m. Well, that's where our peak usage is. So what we want to do with these incentives is take that peak usage and shift it over here into the middle of the night. So it's like your phone. You use it during the day, you charge it up overnight, and it's good to go the next morning. So that's what we're trying to do with some of the price incentives that we have. We're also working on developing some commercial and fleet electric vehicles, and working with some of the owners there. We've been working with Amazon at distribution center they have on some of their fleets. So some things we're doing there.
That's awesome.
This is the thermostat control I told you about. We've been doing this for a while. We just got a new system to do this. Rather than cycling the air conditioner system on off every 15 minutes, we know when the control period's coming. So if we want to have the air conditioner off starting at 5 o'clock, we'll pre-cool 2 degrees under the typical set point for 90 minutes before that control period, and then raise the set point up 4 degrees during the control period, which is typically anywhere from 2 to 4 hours long. And if the house gets warm enough to hit that increase 4 degrees, well, then the air conditioner can still turn on. And then when it's done, then it goes back to the normal set point and it cools the house back down. This has been very successful, and we've had a lot of people enroll on this, and we're looking to try to expand this a little bit. Been a good savings for us. We pass the savings on to the members.
Tom, are you guys seeing a lot of heat pumps going in to your area?
We did for a while. I don't think there's been as many recently. We still do some control on those as well. And to be honest, I've not worked in that particular program, so I can't speak to it real well. But if there's some questions on that, please email me and I'll find them out and get answers to you. How's that?
Okay. Oh, I might do that.
Okay. Well, that was a whole mouthful. That's really what I had to share here today. So if there's any time left, we can certainly entertain any other questions you might have.
I love that. I love that pollinator there.
I thought that was kind of fun. I did not put that slide together, but I thought it was kind of fun.
Yeah. Any other questions from anybody? I just want to thank Tom so much for doing this. This is his last presentation prior to retiring. So we were just lucky to get him while he was still there, kind of thing. And so a major thank you to you, Tom, for putting this together and updating us on some of the stuff that you guys are doing. And if there's no other questions, maybe we'll call it quits for tonight, and MRES people will move on to their next meeting. Oh, James, have you still got a question?
Yes, Doug. Thank you. I was just wondering, Tom, if the Nextera does any battery maintenance, or is that some? And on the HVAC cooling and heating system, is there maintenance? And on the batteries, and do you have to do that, or are they contracted to do that? And about how often does that happen?
That's a great question. Thanks, James. Yes, Nextera owns.
That's Tom. That's two for him now. He's gotten two great questions.
Oh, that's great. Thanks, James. Yeah, they with this setup, the energy storage agreement is the battery supplier, in this case Nextera, or I should say the developer. They purchase the battery, so the battery supplier is whoever they purchase them from. But as a developer, they own and maintain the batteries. So that includes everything about the battery and everything internal to that battery yard in the substation. That includes the AC disconnect switch, the step-up transformer, the battery containers and everything in them, the inverters and the whole bit. So for maintenance, I think they typically would take them offline about once a year and do a checkup on them and make sure everything's good and then put them back in service. And that doesn't take very long to do that. They're down for a day or two and that's about it. Now, if something's broken, it takes a little bit longer. But yes, they do that. Now, if we had purchased them and owned the batteries, then that would be on Connexus Energy to take care of that maintenance. And we're not staffed to do that. So we would have likely have contracted that out to somebody who does take care of batteries.
Thank you.
Okay. Peter, one more?
Yes, I've heard anecdotally at least, farmers and rural folks don't like the solar in the fields out there. They'd rather have wind energy, if anything. Any knowledge there?
That's a good point. When we went and did some land searching, we tried to find places of land where it would fit with the grid, and that land couldn't be used for anything else. And actually, in those cases there, it was a suburban neighborhood that didn't want those solar panels next to their backyard. So where we have them in the field, one of them is owned by, the area is owned by Anoka County, and we lease from them. The farmer next door wasn't so crazy about that, but when we put the pollinator habitat out there and some beehives and that type of thing, well, the bees would fly all over the place, and he's got fruits and vegetables that he grows right next door, so that ended up benefiting him. The other place where we have this planted on farmer's land is land that he had identified as, yep, you can use that for the land. That's not going to take away from my production, and this will help my cash flow with the family. So that worked out just fine there. But it's a mixed bag. It's often people who don't want the solar panels next to their property, or there are some that think that having the solar panels out there is taking up good farmland, and there's some argument to that. So it's been a little bit of a mixed bag. But where we currently have these set right now has worked out pretty well for everybody, fortunately.
There's a major push with agrivoltaics and, running sheep underneath and everything.
Yep.
In fact, the last time I was at Connexus, they actually had a guy delivering sheep to do some grass cleanup under their panels.
Yep, we did that. We've had sheep in here. Also, we did do a little bit of farm planting in the solar panels right here on our site too, as a trial. We grew some fruits, grew some vegetables, had a local farmer come in and do that, and he maintained it. And I don't know if we have any specific plans to do that again anytime soon, but it was a good trial run on that. And the University of Minnesota was out here doing some research along that line too. So there's some opportunities there.
Yeah.
Okay, thank you.
Yeah. Thanks, Peter.
I have just one on that note. Tom, my name is Chris. I'm on the board of MRES. I just came from Chicago area, and the primary elections are going on there. And listening, reading the paper, just picking up on what Peter's saying. One party, I'm going to say, all three of them contenders for that party spoke against solar fields in Illinois, and for different reasons, but mainly food production and all of